Morning, everybody. I'm Thad Cleary. I'm not Pete Vincent. So usually this presentation is much longer, much more technical, but we only got about 12 minutes, so I'm going to give you the whole thing. Pete's the GIS modeling guy. I'm the farming guy with this. So I'm going to start out with kind of explaining, we're with the nonpoint source program at EGLE. We provide grants for developing watershed plans, for implementing watershed plans. And what we found with our watershed planning grants, we were taking 2 years and we were spending tens of hundreds of thousands of dollars to develop these watershed management plans. And at the end, for agricultural watersheds, we would come out to say, yeah, we need filter strips and no-till and cover crops and nutrient management. But we didn't know where we needed those practices. And it doesn't take 2 years to take an ag watershed and say, yeah, we need to have those practices. So what we developed was this agricultural inventory process. And the purpose of the process is basically two things. Number one, utilizing the natural landscape. What are the natural characteristics out there on these farm fields, at these farm operations? And then how are those fields being farmed? Those are the things that are going to impact what's the potential for those fields to have an impact from sedimentation to nutrients to E. coli, impacting surface waters. And then the other purpose was to collect this information for, like the local conservation districts, NRCS, to basically use this information when they're going to be working one-on-one with farmers to get practices on the ground. So we basically have three components to this process we developed. The first is a desktop analysis component, which is like looking at aerial photos, getting information that way. The second component is a field inventory process, and then the third component is the modeling component of it. With the desktop analysis part of it, one of the first things we have to have with this is to have actually digitized field boundaries of every crop field in a given, in this case, this is a Huck 12 watershed in the Bean Creek. So have all of those fields digitized. That's necessary for collecting the data on what's going on in those fields, as well as then running the model later on that we'll get to. And we actually, for the Western Lake Erie Basin, through a Herb Family Foundation grant, the Environmental Working Group has actually digitized. We have all crop fields within the Western Lake Erie Basin digitized for the entire watershed. The next component of the desktop analysis is then taking those crop fields and identifying which of those fields are within a certain distance of surface waters. Obviously, the closer they are, the more potential impact they could be having. So in this case, we just looked at how many of these fields, there was 604 fields in this sub-watershed, and out of those 604, 139 of those fields, a little over 4,000 acres, were actually within 50 feet of a surface water body. From there, we take those fields that were within 50 feet, and then using aerial photography, identify which of those fields actually have filter strips. So not just a natural buffer, but an actual filter strip that the farmer planted between the cropland and the surface water. And you can see there was 41 of the fields, a little over 1,300 acres actually had filter strips in place. The remainder of the fields did not have any filter strips in place. Another component of the desktop is livestock operations. So in regards to CAFOs, the concentrated animal feeding operations, EGLE permits those facilities. So we have information on where those operations are located and where they potentially spread manure. So the red diamonds are the actual locations of CAFO operations. This is the Bean Creek Watershed as an example. We identified some of those CAFOs outside of the watershed because they still could potentially hauling manure into this given watershed. And then the brown fields here are fields that on any given year they potentially may apply manure to. Doesn't mean they're going to every year, but these are the fields that they've identified. This does not include manifested manure. Manifested manure in the CAFO permit is any manure that they actually give away. They don't apply it on their own fields because we do not have that information at this point. So it's not the entirety of the manure generated at CAFOs. The next thing is, again, through aerial photography, looking at and identifying where are the rest of the livestock operations. The small and medium ones, those would be the yellow diamonds here. And then also there's a lot of hobby farms. You'll find a lot of places with some horses or a few cows, and they could potentially be having impacts depending on what their practices are. So just because they're on here doesn't mean they're causing a problem. We just identified what was in the entirety of the watershed as far as the livestock operations. As we are going through the aerial photos, we do look for, can we see evidence that something's occurring? Do you see livestock having access from in pastures to streams? Do you see feedlots, that there's likely runoff going from those feedlots getting into surface water? So we will identify that. And then like the conservation district can follow up, drive the watershed, see what they can actually see from the road and collect some more information to put in their watershed plans. And then the second component of the ag inventory process is our field inventories. So this is basically the conservation districts are going out, driving the watersheds 2 times a year to go out and collect this information on a field-by-field level of what's actually occurring, how are these fields being farmed in a given watershed. So the first thing, they'll go out in the fall after all tillage is done. You want to wait until all tillage is done because you're trying to document the amount of tillage. But the first thing you're going to document is, okay, what was that previous crop? What was grown in that field this year? And so here you could see this watershed was dominated by corn and soybean. Actually, those numbers I don't think are right, so don't pay attention to the numbers. It was corn and soybean dominated for sure. The other aspect is when driving the watershed, there's going to be certain fields you are not going to be able to see from the road. So that's the gray ones, that's the no data collected. On average, we're usually somewhere between 20 to 25% of the fields you're actually not going to be able to collect any of this data on because you just physically cannot see it. The next piece is the tillage practice. So here we're looking at, what type of tillage are they actually doing? Are they, chisel plowing, doing mulch tillage, or is there no tillage done? The other thing is, are they planting cover crops? So we're documenting that as well in the fall. Which fields have cover crops planted on them? Which ones have a crop like a winter wheat, so there's actually vegetation out there. The big thing, the reason we're collecting the crop and the tillage, because if you know the crop and you know the tillage practice, it gives you a good idea of how much residue is going to be left on that field over the winter and early spring. If you have a soybean field that was chisel plowed, there's not going to be much residue out there, and that field is going to be more susceptible to erosion than, say, a field of corn that was harvested for grain that had some light mulch tillage or had no tillage done. So that's why we're collecting the two to try to evaluate that risk of that field. And then finally, in the spring, the Conservation District staff will go back out after planting is complete, and they will document how much residue is out there left on those fields after planting. So we have basically 4 categories. We have greater than or less than 30%, basically using NRCS's number there for more susceptibility to erosion and less if it's more susceptible if it's less than 30%. We have no-till plant, and here we're assuming if it's no-till plant and it's above 30%, but we also just want to be able to track and see how much no-till is actually occurring in a given watershed in a year. And then the 4th category is just there's 0 residue out there, which obviously is going to give the least amount of protection. And then on to the 3rd component. So this is the part that Pete usually talks about, the GIS and the modeling component. So the Agricultural Conservation Planning Framework tool was developed by the Agricultural Resource Service out of Ames, Iowa, part of USDA. And it's basically, the ACPF, it's a set of GIS tools used to locate suitable sites for conservation practices to be implemented. But in addition to suitable sites, it also gives you other information. So on the top picture there, you can see the green lines, the flow lines that the ACPF tool will generate. And so it's basically, it will show you, as a conservation district staff, NRCS staff, you could actually know where water is going to flow across any given field before you even go out there and start working with the farmer. And I think that's, and it's actually, based on what we've seen, the data, it's very accurate on doing it. It's based off LiDAR, digital elevation models, and it's pretty spot on, actually. In addition to the flow paths, the ACPF tool also identifies the slope in any given field. So it will break those fields down into either the mean slope you can get, the 75th percentile, or it's broken down into what percentage of the field is in a given slope range. As you can see, there's examples there of 10 to 15% or 5 to 10%. So all those different slope ranges are available. And then the third thing is the site-specific practices for any given field. And in this example, this is the red on the right there, those red kind of flow lines, is showing you where the ACPF tool identified there's the potential need for grass waterways. So it means you have concentrated flow going on, and you have the potential for erosion there. And on the left in the aerial photo there, you can see that red line is laying on top of what already is a grass waterway. So you can see the ACPF tool does actually a really good job of placing that practice on the landscape based on what was out there. So again, to go back and cover what we're collecting this information for and what it is. So we're getting fields that are in proximity to water bodies, the slope of the fields, the surface water flow paths across those fields, what the crops are, what the tillage practices are, where cover crops are being used, what's the amount of residue after planting, where are filter strips and where not, and then where are the livestock operations located in the watershed. And then the next step is then taking that information and trying to identify, going back to our purpose, what are the higher priority fields? Which fields have a higher potential of contributing sediment, nutrients, E. coli from them? And this is just one example out of the Lime Creek Watershed. This is within the Bean Creek. Here we took the red fields are fields that were within 50 feet. And then we looked at that fall tillage data information, we looked at the spring residue information, and we looked at what fields had the potential for CAFO manure, and came up with, you could see, 94 fields, a little under 4,900 acres of priority. Our intent here was to get somewhere between 25, 35%, identify the highest percent of fields. We're working in a voluntary program. You know, not every farmer is going to want to participate, so we need to have, you know, a number of fields identified that those conservation district staff and NRCS can go work with. And so then we wanted to add some more fields to that, so we wanted to look at fields that may be a little further away but actually had higher slopes in those fields, more potential for runoff. So we looked at fields within 300 feet, and then we looked at fields that had, I think it was greater than like a 3% slope. And then again, we factored in the tillage information, the residue information, the livestock, the CAFO information, and we came up with an additional 48 fields. And the two combined, the red and green, is about 31% of the fields in this given watershed. So the key here is just because it's a priority field doesn't mean that every one of these fields is necessarily contributing pollutants. This is where it takes somebody has to, at the local level, go out, work with the farmers, look at the fields, see what the farmer's actually doing. We don't know what's going on with their nutrient management plans because you can't see that through aerial photos. You can't see that from driving. That's going to take somebody working with those farmers one-on-one. So again, these are just, they have the potential, but the thing that's important is I think up to this point, we've always, most programs, even our grant funding, the meat program, the Farm Bill dollars through USDA, everybody's, it's kind of a first come, first serve in the willing. And we need to get past just working with the willing farmers. We have to start identifying where are the impacts coming from and working with those producers. So this is just a kind of a status of what's gone on, where we're at in the Western Lake Erie Basin. You can see there's 75 Huck 12s. The ACPF has been completed in 35 of those. Again, a lot of that work was done through an Herb Family Foundation grant to the Environmental Working Group to do that, and the Environmental Working Group is actually working on another 15 Huck 12s right now to complete the ACPF tool. There's 18 hucks, it's kind of the white areas that are remaining where the ACPF is not done yet. And we're hoping that we can actually probably try to get that done within the next year, year and a half or so. Field inventories have been conducted in 10 watersheds. That's where the conservation district's going out. That takes more time. In that field inventories, one thing I didn't mention, going out and driving, you only can cover so many watersheds. So we are actually working with a couple of companies using satellite imagery to, instead of having to go out and drive, using that satellite imagery to identify what crops are being grown, tillage practices, amount of residue, with the intent of hopefully at some point, it would be at a cost, but of getting data from any watersheds that we want at any time. Even we can go back in time to 2016, I believe it is, with our imagery data. And that's it. And now I think we're ready for questions.
You can go sit. Yeah.